Well, we had just seen this example, but just one more time. So we can reassign the values. Like, let's say that x is equal to 0.6. And then we want to do this calculation. Okay, the thing here is that when I say x is equal to this calculation, I am still using x. So I'm updating the value of x, but using the value of x. This is something that we commonly do. So what happens here is that when we first do the right side of the expression, at that point, the value of x is not updated yet. So it's still 0.6. So 1 minus 6 and 1 minus x will be 0.4. And then we will do this all the calculation. Then the result will be 0.936. Then we will update it. Then the value of x will be not anymore 0.6, but it will be 0.936. So when we are doing a reassignment, we can still use the value because at the right side it is not updated yet. Once we finish that calculation, then we will update it. And in Python, actually reassignment is very flexible. Like we can even assign different data types. Like I can say x is 99, then I can say x is a string now, and its value will be take me to your leader. So this is valid. For instance, in Java, this wouldn't be valid. You cannot you can do a reassignment, but you cannot change the data type. But in Java, it is valid. So I can say x is 99, then I can say x is ABC, then I can reassign that, okay, x now will be a numerical value of 5. So this is all valid. So you can even change the data type. What is happening is, well, from now on, the thing will be a more technical detail. What is actually happening in the memory is, when I say x is equal to 99, we write 99 in the memory, and x is referring to that value. But then when I said x is equal to now take me your leader as a string, what will happen is that this value will be still in the memory, but Python will just write create a new value for the string, and then it will change the address that it refers. So x will not be anymore referring to the 99, but it will be referring to this part. Then the question is, okay, what will happen to this 99 value, because it's still in the memory. Now the good thing with the Python is that you don't need to worry about that, like because Python has this garbage collection system. What it means is that time to time it scans the memory and then detects the data that is not used anymore, and it removes them from the memory. So you don't need to worry about, okay, I said 99, then to a string, then a number again, then a string again, and there are so many data that I'm not using anymore. What will happen? It won't have. You don't need to worry about it. But in some other programming languages, like C programming languages, for instance, yeah, you have to, if you use the data and not using it anymore, you yourself have to take that data and remove and free up your space. Otherwise, at some point your memory might be full with all these data that you are not using anymore, and then the programs that you are using might crash because of this. But we are not learning C, so in Python you don't need to worry about this memory management issues. So you can just proceed as follows. And I will talk about this, but I need to first talk about it, then we'll come back to that slide. So again, just as a reassignment example, let's say that we have $2.75, then I'm printing it. Here is this syntax that we didn't see. For now, just let's skip that. I will talk about it right after this example. So I'm basically saying I have dollars in my account. What is dollars? It's 2.75. So I will first print this. I have 2.75 in my account. Then I will change the dollars to 99.95. Then when I say, but I now have dollars in my account, so now I will print, it will print, but now I have 99.95 in my account. So when we change the value of it, then always the latest value that we assign will be used. So what is this printf? Let me show this. Well, when we are writing a message, printing some message, we want to use some variables and so on in my message so that it will look nice, and so on. How can we do it? Well, there are multiple ways to do it, but the first one is, well, we can also do, let me clear my screen first. For instance, I can say, okay, I have, let's first actually do this. Let me, the dollars is 2.75. Then I want to say, okay, print. How can I say I have $2.75? One way I could say is I have. Then I could put a comma, and then I can say dollars, and then one more, and then I could say dollars. Well, no, dollars in my account. So this would be one way to do that. So a print function, as we had seen in the last lecture, we can put multiple strings and then we'll put a space. But, I mean, it's not very intuitive actually, because I'm actually putting 3 different variables. I could also do this, like I can put I have, and then I can concatenate them with this, and then that would be still valid. Yeah, and we will get into these kind of problems. We didn't see this part, but anyway, I can also still do that. I can concatenate it. But the thing is that in these 2 examples, I need to check that, okay, did I close? I need to put them in double quotes. And then the dollars in my account, I have to put them in also double quotes. And I'm breaking this sentence, so it makes it confusing. So again, I'm lazy in typing. I don't want to lose time with some easy stuff. The F string, the formatted string, solves this problem for me. So instead of breaking a string, what I'll do is I will use an F string, which has this format, F, and then the quotes, and then I will write my sentence. Full sentence without breaking it down. I have dollars. Now for the dollars, I don't want to write 2.5. I want to use my variable name. So I put them in the curly brackets, and I said dollars, and then dollars in my account. It will do exactly the same thing. But now, you might find this easier. The reason is that I'm not breaking the sentence into multiple parts and then trying to merge them and so on and so. But I just write my sentence, and then it will work as it is. And the problem in the first 2 examples would increase if in my sentence I would need multiple variables. For each of them I need to do this concatenation, dividing, and so on and so. But in this kind of F string, it would be 1 string, and whenever you need a data value of a variable, you will just put them within the curly brackets, and then it will do the trick. All right. Do you have any question about F strings? Not. I'm moving on. So in that example also we were using that F string. And the previous slide was also about that. All right. Now, also I need to talk about the data types when we are talking about the variables. So a variable can be an integer. What is an integer? An integer, I will use it for the whole numbers that doesn't have any decimal point, like 3, 5, 10, 100, minus 50. These I will call them integers, and int. This stands for integers, and in the code we will use this int for some operations. So whenever we say int, it means the whole numbers. And then the float. What is a float? Well, this, again, the naming is not very intuitive. It actually means real number. So a number with decimal points, like 2.5, 3.7, 1.0. So still it's a real number. For those data types, you will say it's a floating number. It's a floating point number. And then for the strings, again, if I say str, this is a keyword, this is a function name. like as I used in my Python code previously here. So basically it means string, text data. So for these parts, first the numerical values. So I can put the numerical values to variables like 12, 0, and so on. Then it will be an integer data. But if I use a decimal point, then it will be a floating point numbers. So for this literal, I mean that it is the data that we directly put in our code, like 3, 5, 7, and so on and so. So numerical, integer literal, or the floating point literals. The other thing is the lists. So we will see much more detail in chapter 7 about what a list is, but let me give you one example. We use computers to deal with large data. Like if my data is very small, I wouldn't need a computer. Like if I just bought 2 items from the grocery, then why should I write a program for that? I can do it myself. But if I'm running a store and every day I'm selling 1 million items, then I need a computer to do that. So I need to deal with the large data. Let's say that for this class, I want to calculate the average score in the midterm, okay? Then what can I do is, from now on what we learned is, for each of you, I can define a variable, like maybe with your names, like, I don't know, Fatima, score is this one, Aisha is this one, and so on and so. But the problem is that then I need to define 50 variables. That's huge. Like, again, my motivation is that I don't like typing. And then I need to deal with 50 different variables. That would be pretty problematic. So what I can do is, instead of that, I create a list. Like maybe students in class or scores of students. And then I use this notation, square brackets. And then I will put all my data in that. Each of them is with comma separated. So I will not need to think about 50 different variable names. I'll just say scores of class. So it's much more easy to find a name, because like 50 different names would be even problematic. So then what will happen is that my data will be in this list, and I will be able to reach all of them like by using this index value. So what is an index value? If I have an index, I will be able to say that, okay, give me the student in the index 1, index 2, index 3. I know that there are 50 students, so index will be go to up to, I know that there up to, now this would be challenging. Not if I have 50 students, the index will be 49. Why is that? Now this is also again something that is different than the other fields. Like if I tell you that, can you count to up to 10? How would you do that? Where will you start? Which number will you start? 1. Yeah, normally we say 1, 2, 3, 4, 5, 6, and so. But in computer science, we start counting from 0. So if you tell me like, okay, count up to 10, I will say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So always our starting point is 0. There's a technical reason for that, but when for our list also, the index of the first item is 0. Index of the second item is 1. So index of the last item, the 50th item, will be 49. So this is, but we will see this in much more detail in the chapter 7. But basically, yeah, we use list if we have a long list of data. And now I want you to answer these questions, like complete this statement to display the value in y incremented using f string. Now, I don't want you to get shocked when you see the quiz questions, but quiz questions will be pretty similar to these type of questions, okay? So for this question now, again, so you really have to know the syntax. So basically, I need to write a print message, okay, by using the f string, in which I will also increment y, the value of y by 1. So I don't want to write a print 21. But I want to write it in 1. How can we do it? Do you have an idea? So let's do this in part. So we have this I is equal to 21. I is 20, sorry. And I want to use it with a printf message, with an f string. So I need to say, okay, it should be something like this. Print message, open parenthesis. I need the first letter is f, then the quotes. Then in between, I need to write this. If I say y, it will be 20, because the value of y is 20. But if I increment it by 1, it will be 21. All right, so let's do the other question. Assign the value 80 to the variable name. So what it means is, then it will print. But the only thing that I need to do is now just do this assignment. How can I do it? Assign the value of 80 to the variable num. Yes, exactly. So basically, I just need to say num is equal to 80. That's it. This is the answer. And what is the output? X is 30, X is hello world, and then print X. Hello world, yes. So it's 10:50. I should stop here. This is the class for today. And thank you for your attendance. If you have any questions, I can take. If you need to leave, where you can leave. If there's